Did you know that the universe isn't just made up of stars and planets, but also contains enormous galaxies that stretch across millions of light years? Why do we call galaxies the building blocks of the universe, but often overlook the mesmerizing complexity within them? Galaxies aren't just twinkling dots in the night sky. They are vast cosmic wonders where countless phenomena unfold, many of which we are only beginning to understand. In fact, galaxies are at the heart of how the universe evolves, connecting everything from tiny stars to unimaginably massive structures. Yet, many people misunderstand what galaxies truly are. Some think galaxies are nothing more than random clusters of stars and cosmic dust, unaware that these are intricate systems governed by gravity and essential to the existence of everything around us. Others doubt the existence of larger structures, like superclusters or the cosmic web, dismissing them as mere theoretical concepts. But are these assumptions accurate? This video will unravel the truth, taking you on a journey to explore the wonders of galaxies and the colossal structures that hold the universe together. Imagine each galaxy as its own miniature universe, far bigger than we can truly grasp. On average, a galaxy contains hundreds of billions of stars, along with clouds of gas, cosmic dust, and a supermassive black hole anchoring its core. These components don't just exist side by side, they interact in fascinating ways, driving processes like star formation, supernova explosions, and the flow of cosmic energy. Beyond that, galaxies are also home to dark matter, an invisible yet critical element that maintains their structure and shapes their evolution over time. It's astonishing to think that, from a primordial universe after the Big Bang, hundreds of billions of galaxies emerged and organized themselves into colossal cosmic networks. These networks are not chaotic webs of random matter. They are carefully woven strands of galaxies, bound by gravity and streams of dark matter. Superclusters, the largest known structures in the universe, are key pieces of this vast puzzle, connected through gravitational forces that paint a breathtaking picture of the cosmos. Every galaxy and every massive structure plays an irreplaceable role in this intricate, ever-expanding universe. But the truth about galaxies and the universe's large-scale structures isn't just about mind-blowing numbers or complex physics. They prompt us to ask deeper questions. How do galaxies connect to form such vast networks? What role do dark matter and dark energy play in orchestrating the universe's movements? And could it be that galaxies are home to extraterrestrial life, waiting to be discovered? These questions not only spark our curiosity, but also pave the way for groundbreaking scientific discoveries yet to come. To dive deeper into these mysteries, join us in exploring the incredible story of galaxies and the cosmic structures that shape the universe. Let's embark on a journey to uncover the majestic secrets of the cosmos, where every discovery brings us closer to understanding our place among the stars. Have you ever wondered how the magnificent galaxies scattered across the universe came to be? They didn't always exist in the luminous forms we see today through telescopes. In the beginning, galaxies were merely faint clouds of gas and dust. But over time, they underwent miraculous transformations to become the cosmic wonders we now explore. Yet, did you know that galaxies didn't evolve peacefully? They endured dramatic collisions, powerful interactions, and were held together by an invisible force. Let's dive into this fascinating story. Billions of years ago, the first galaxies weren't vast, majestic structures. Instead, they were born from nebulae, enormous clouds of gas and dust floating in the infinite void of space. Imagine gazing at a dim mist stretching endlessly, containing tiny particles of matter waiting to form something extraordinary. Gravity started to take hold, pulling these particles closer together, creating dense regions. Over time, these regions formed the first clusters of stars, eventually giving birth to larger structures. Nebulae were not just cradles of creation, but also determined the initial characteristics of galaxies, such as their size and shape. Scientists estimate that the formation of galaxies began approximately 13.5 billion years ago, only a few 100 million years after the Big Bang. For example, our own Milky Way is believed to have originated from small gas clouds that merged over billions of years. Observations made with the Hubble Space Telescope allow us to see ancient galaxies, much smaller than those we observe today, but they were the foundation of the modern universe. Not everyone agrees that gravity and the collapse of nebulae were the only forces driving galaxy formation. Some researchers suggest that the first supernovae explosions triggered shock waves, sparking star formation and accelerating the creation of galaxies. So, which played a bigger role, gravity or these violent cosmic events? The answer remains a mystery. As galaxies began to form, they didn't exist in isolation. Instead, they interacted, collided, and merged with one another, leading to more complex structures. Imagine two enormous galaxies hurtling toward each other at hundreds of thousands of kilometers per hour, finally merging in a chaotic dance of stars and gas. These collisions didn't just destroy, they reshaped galaxies entirely, creating new types of galaxies in the process. Astronomers have documented many examples of galactic collisions. One particularly intriguing example is the future collision of the Andromeda Galaxy and the Milky Way, set to occur in about 4.5 billion years. Computer simulations suggest that when this happens, the two galaxies will merge to form a giant elliptical galaxy, transforming their appearances forever. Interestingly, these collisions don't always result in total destruction. Instead, they can trigger bursts of new star formation as gas clouds are compressed by gravity. However, not all researchers believe these interactions are beneficial. Some argue that mergers can lead to the destruction of stellar systems and even slow down star formation over long periods. So, are galactic collisions forces of creation or destruction? This question remains a topic of ongoing debate. Another often overlooked yet crucial element in the evolution of galaxies is dark matter. Though invisible and intangible, dark matter makes up 85% of the universe's mass and is essential for holding galaxies together. It acts like an invisible framework, binding stars, gas, and dust, while preventing galaxies from falling apart as they spin. Scientific studies have shown that galaxies couldn't exist without dark matter. For example, the outer stars in galaxies orbit much faster than their visible mass can explain. This discrepancy points to a massive, unseen presence keeping everything in place. Observations from telescopes like Gaia and simulations of the universe strongly support the undeniable presence of dark matter. But what exactly is dark matter? The question remains unanswered. Some theories suggest it's made of yet undiscovered fundamental particles, while others argue it might be a flaw in our understanding of gravity. Does dark matter truly exist, or is it just a placeholder for what we don't yet understand? The mystery continues to challenge scientists worldwide. The evolution of galaxies is a story full of drama, from their beginnings in nebulae to their chaotic collisions and the stabilizing influence of dark matter. Each element plays a vital role in painting the grand picture of the universe, helping us better understand how everything works. But how many more secrets remain hidden? Unanswered questions about dark matter, galactic interactions, and chaotic origins inspire us to keep exploring this vast, awe-inspiring cosmos. The universe, with all its grandeur and enigma, always beckons us to venture further in our quest for truth. Have you ever wondered if life exists somewhere beyond Earth, among the billions of galaxies in the universe? This curiosity has persisted for centuries, but the vastness of space means we've barely scratched the surface of exploration. Galaxies are not just collections of stars and planets. They could be cradles of life. But what determines whether a region in a galaxy can support life? And among the billions of stars in the Milky Way, are we truly the only species capable of contemplating our existence? Within every galaxy, not all areas are suitable for life to emerge and thrive. Scientists have identified regions called habitable zones in galaxies, where the environment is relatively stable and less affected by dangerous phenomena like intense radiation or supernova explosions. Imagine the Milky Way as a giant disk, with its blazing, energetic center too hostile for life, while its far edges are too barren to sustain it. The habitable zone lies in the middle, where stars and planets have enough essential elements for life to take root, like rocky planets and water. According to research, this zone is located about 25,000 to 35,000 light-years from the Milky Way's center. Our solar system, for instance, is situated within this zone, possessing all the necessary conditions for life to arise. Data from the Kepler Space Telescope also suggests that roughly 20% of Sun-like stars in this zone could have planets within their own habitable zones. This opens up exciting possibilities that life might not be confined to Earth alone. However, not everyone agrees with the concept of a galactic habitable zone. Some scientists believe that radiation from the galactic center could create unique conditions to spark life rather than destroy it. Are we limiting our perspective by only seeking life in safe areas? Perhaps life in the universe is far more adaptable than we've ever imagined. From galactic regions, the search for life extends to planets within the habitable zones of stars. These are places where temperatures are neither too hot nor too cold, allowing water to remain in its liquid form, a fundamental requirement for life as we know it. But do such planets really exist? Or are they simply a dream fueled by science fiction? Based on observations from the Kepler Space Telescope, scientists have discovered over 5,000 exoplanets, of which around 50 are believed to lie within their stars' habitable zones. One standout example is Proxima Centauri b, a planet orbiting the star closest to our solar system. It is roughly the size of Earth and located about 4.2 light-years away. Although conditions on the planet require further investigation, its discovery has reignited hope for finding life beyond Earth. But what if life exists in forms we've never encountered? Perhaps liquid water is not the only factor that matters. Some suggest that in extreme environments, such as the icy moons of Jupiter and Saturn, like Europa and Enceladus, life might survive based on other compounds like methane or ammonia. This idea opens up an entirely new realm of possibilities, challenging our traditional understanding of life. Our Milky Way, with its billions of stars and trillions of planets, is a galaxy rich with potential for intelligent life to evolve. But could life like ours truly be the only one in this vast expanse? Scientists have pondered this question for a long time, and the answers remain elusive. One fascinating theory is the Fermi paradox, which asks, if intelligent life is so common, why haven't we seen any evidence of it yet? Some suggest we might be in a silent bubble, where other civilizations are either too primitive to communicate, or so advanced that they've moved beyond our reach. Or perhaps extraterrestrial civilizations deliberately avoid revealing themselves for security or ethical reasons. It's hard to imagine that among the hundreds of billions of stars in the Milky Way, Earth is the only place where intelligent life exists. If that's true, it raises an even greater question. What responsibility do humans have to protect this rare life? And if we're not alone, how would the discovery of another civilization transform our understanding of our place in the universe? Every region of a galaxy, every planet, and every potential sign of life adds to the greater narrative of the cosmos. From habitable zones in galaxies to planets capable of sustaining life, and finally to the possibility of intelligent civilizations, each step brings hope and challenges for human exploration. Yet, the question remains: if life is rare, how do we safeguard its preciousness? And if life is abundant, are we prepared to meet it? The answers lie ahead, in the uncharted frontier of our exploration of the universe. The story of galaxies through the lens of Hubble. Have you ever gazed at the night sky and wondered what lies beyond the stars twinkling above? Out there, beyond what our eyes can see, are galaxies. Massive, breathtaking collections of stars, gas, and dust, spinning in intricate patterns or drifting in quiet stillness. But did you know that not all galaxies are the same? Thanks to the groundbreaking work of astronomer Edwin Hubble, we now understand that galaxies come in different shapes and forms, each telling its own story about the universe's origins and evolution. Among these, spiral galaxies mesmerize with their graceful arms, elliptical galaxies stand as quiet giants, and irregular galaxies defy all conventional rules, forming chaotic masterpieces. Let's take a journey through these cosmic wonders and uncover the secrets they hold. Imagine floating through space, seeing a grand spiral of light and stars stretch out before you. That's what a spiral galaxy looks like. A magnificent structure with glowing arms of gas and stars gracefully winding around a bright central core. The Milky Way, our home galaxy, is a perfect example. These spirals are not just visually stunning, they are hubs of activity where stars are born, nurtured, and shine brightly. The arms are like cradles of creation, full of the raw materials needed for new stars to form. There's something profoundly poetic about how these galaxies seem to reach out, their arms spanning tens of thousands of light years, holding the mysteries of the cosmos within their grasp. Scientists estimate that spiral galaxies make up about 70% of all galaxies in the universe. For instance, Andromeda, our closest spiral neighbor, is a colossal galaxy with a diameter of 220,000 light-years, nearly double the size of the Milky Way. What's more fascinating is how these galaxies rotate. Their arms should, by all logic, scatter and lose their shape over time, but they don't. This puzzling stability is one of the strongest pieces of evidence we have for dark matter, a mysterious substance that makes up most of the universe's mass but remains invisible. Spiral galaxies, therefore, hold the key to understanding not just themselves, but also the unseen forces shaping the cosmos. Still, their beauty isn't eternal. Some theories suggest that collisions with other galaxies could distort or even destroy the elegant spirals we see today. It raises a compelling question. Will the Milky Way and Andromeda, destined to collide in a few billion years, lose their iconic shapes and merge into something entirely new? The thought reminds us of how fleeting even the grandest structures in the universe can be. Now, picture something very different. Instead of elegant spirals, you see a massive, smooth glow of stars without any clear structure. That's an elliptical galaxy, a monument of simplicity and age. Unlike the dynamic, star-forming spiral galaxies, elliptical galaxies are filled with old, dim stars and have almost no gas or dust left to create new ones. They're like cosmic relics, silent witnesses to a bygone era of star formation. Recent studies with the Hubble Space Telescope reveal that these galaxies are often found at the centers of galaxy clusters, where their immense gravity pulls other galaxies toward them. One such example is Messier 87, M87, a giant elliptical galaxy spanning 120,000 light-years. Its heart holds a supermassive black hole with a mass 6.5 billion times that of the Sun. A black hole so powerful, it bends light itself. These ancient giants may seem lifeless, but they are pivotal in shaping their surroundings, acting as anchors in the vast ocean of space. Yet, there's an enduring mystery about them. Why are elliptical galaxies so devoid of the gas and dust needed for star formation? Some believe they've consumed all their resources over billions of years, while others suggest violent collisions stripped them bare. Could these galaxies ever regain their vibrancy, or will they remain as eternal monuments to the universe's past? It's a question that keeps astronomers pondering. And then there are the rule breakers. Imagine walking into an art gallery and seeing a painting that doesn't fit into any style you know. Its lines chaotic, its colors clashing, yet somehow it captures your attention. That's what an irregular galaxy feels like. These galaxies don't conform to the spiral or elliptical shapes. Instead, they are chaotic, often the result of gravitational interactions or collisions with other galaxies. They're the rebels of the universe, defying order to create their unique beauty. Take the Cartwheel Galaxy, for instance. It looks like a giant wagon wheel in space, its circular rings glowing with clusters of new stars. Scientists believe it formed when a smaller galaxy collided with a larger one, sending shock waves through its structure and triggering a burst of star formation. Irregular galaxies are relatively rare, accounting for about 5% of the total, but they provide a vivid reminder of the universe's dynamism and unpredictability. What's fascinating is the debate surrounding these galaxies. Some argue that irregular galaxies are just transitional states, destined to evolve into more conventional shapes. Others believe their chaotic nature might hold clues about the universe's early days when galaxies were just forming. What do you think? Could their disorder be a glimpse into the past, or simply a temporary phase in their cosmic journey? Galaxies, in all their diverse forms, are the universe's way of telling us its story. Spirals, with their graceful arms, remind us of the beauty of creation. Ellipticals, with their ancient stars, speak of endurance and the passage of time. Irregular galaxies, chaotic and unpredictable, show us that the universe thrives on change and transformation. Together, they form the fabric of the cosmos, inviting us to wonder not just about where we come from, but where we're headed. What secrets do they still hold? And how much more is there for us to learn? As we gaze into the infinite depths of space, the galaxies remind us of the vastness of existence and the endless questions waiting to be explored. The large-scale structure of the universe. Have you ever imagined that the universe, so vast and endless when you gaze at the night sky, is more than just a sea of stars? It's a place where enormous structures connect, weaving together into a giant cosmic web. Within this web lie superclusters of galaxies, massive collections of hundreds or even thousands of galaxies bound together by gravity. These are not merely clusters of matter. They are the centers of grand secrets about how the universe was formed and continues to evolve. Let's explore the story of these superclusters and their profound role in the larger picture of the cosmos. Superclusters of galaxies are the largest known structures in the universe, where thousands of galaxies are held together by gravity. Imagine standing on a hill, looking down at a glowing city full of lights. Each galaxy is like one of those lights, But instead of scattered buildings, they form tightly knit clusters, connecting into vast superclusters. Scientists define superclusters as massive structures made up of many galaxy clusters bound together in enormous spans of space, often stretching hundreds of millions of light years. Their role is not just to exist as parts of the cosmic web, but also to serve as the nodes holding other components of the universe together. According to research, a typical supercluster can contain anywhere from 10 to 100 galaxy clusters, with a total mass reaching millions of trillions of times that of the Sun. One example is the Virgo supercluster, which includes our very own Milky Way within its influence. Data from the Sloan Digital Skies Survey has shown that superclusters are the building blocks of the universe, shaping how matter is distributed across space. However, not all scientists agree on whether superclusters are permanent structures. Some theories suggest that as the universe expands, these superclusters will eventually lose their connections, with their components drifting apart. If so, are they truly the central figures in the universe's grand design? Or are they merely temporary formations in its long evolutionary journey? One of the most astonishing superclusters is Laniakea, the home of the Milky Way. The name Laniakea, which means immeasurable heaven in Hawaiian, perfectly reflects its immense size. Laniakea contains about 100,000 galaxies, stretches over 500 million light-years, and holds a total mass of more than 10 million trillion suns. Not only does it house the Milky Way, but it also connects with other galaxy clusters such as the Virgo and Hydra clusters. A groundbreaking 2014 study by astronomer Brent Tully and his team used telescope data to map the detailed structure of Laniakea. They discovered that Laniakea is not an isolated collection, but part of an even larger structure stretching across neighboring superclusters. This finding has deepened our understanding of how galaxy clusters are interconnected across the universe. Yet, Laniakea also raises many unanswered questions. Scientists are debating its true boundaries, as the clusters within it are influenced by nearby superclusters like Shapley. This leads to the question, are there clear borders between superclusters, or are they simply overlapping parts of a more complex structure we haven't yet fully uncovered? Superclusters don't exist in isolation. They are part of the cosmic web, a network of dark matter and galaxies interconnected like a massive net. Picture a spider web illuminated with light, where the threads are dark matter, and the galaxies sit at the intersections. Superclusters are the knots in this web, keeping the universe connected and shaping how matter is distributed. Data from the Planck telescope has provided strong evidence for the existence of this cosmic web, showing that superclusters are linked by bridges of dark matter stretching millions of light years. One of the most remarkable images is a full map of the cosmic web, revealing dark matter filaments weaving between superclusters like lifelines of the universe. These connections not only provide stability, but also help us understand the universe's expansion and evolution. However, some researchers question whether the cosmic web is as stable as it seems. With the universe's expansion accelerating due to dark energy, will these connections endure or eventually break apart? If the web disintegrates, the universe could become a fragmented expanse where galaxies drift in isolation, no longer interacting with one another. The story of superclusters is a testament to the wonders of the universe. From their role as central hubs connecting galaxies, to the grandeur of Laniakea, our home, and finally to their relationship with the cosmic web, they create an inspiring and vast picture. But what will happen as the universe continues to expand? Will these superclusters and their intricate web of connections last forever? Or are they temporary structures in the endless flow of time? The answers remain beyond our grasp, waiting for the next steps in our journey to uncover the mysteries of the cosmos. Have you ever wondered what the universe would look like if we could see it from above? Would it just be an endless void filled with stars? Or would it reveal a more complex picture, with threads of matter weaving everything together? In reality, our universe isn't just a chaotic mess of galaxies. It's structured as a massive network, a cosmic web. This is not easy to imagine, but the cosmic web holds the key to understanding how matter is distributed and organized in the infinite expanse of space. The cosmic web is one of the most wondrous and intricate structures humanity has ever discovered. Picture a gigantic spiderweb stretching across the universe, where dark matter filaments form the threads and galaxies sit at their intersections. This is how the cosmic web works. Filaments spanning hundreds of millions of light years connect galaxy clusters, creating a universal network. These dark matter filaments, though invisible to the naked eye, are foundational, acting as the skeleton that holds everything together. Data from the Planck telescope and the Sloan Digital Sky Survey, SDSS, have allowed scientists to create detailed maps of the cosmic web. These images reveal that dark matter filaments not only connect galaxies, but also shape how they are distributed in space. A 2021 study showed that these filaments can stretch up to 10 million light-years and make up most of the universe's mass. However, the cosmic web remains a great mystery. Some scientists question whether dark matter truly exists, or if it's merely an explanation for phenomena we don't yet understand. Without dark matter, could the cosmic web maintain its structure? Or is it simply a random arrangement? These questions challenge us to deepen our understanding of the universe's essence. The cosmic web isn't just a marvelous phenomenon, but also a legacy from the universe's earliest moments. After the Big Bang around 13.8 billion years ago, matter in the universe wasn't evenly distributed. Tiny irregularities in the sea of primordial energy gradually formed dark matter filaments, eventually creating the cosmic web. In these regions, the first galaxies were born. Scientists use computer simulations to recreate the formation of the cosmic web. For example, the Illustri's TNG model has recreated how matter condensed into filaments, forming the web-like structure we see today. These simulations also reveal that the cosmic web continues to evolve as gravity pulls galaxy clusters closer while the universe expands outward. But is the cosmic web a universal phenomenon, or merely the result of a series of random events in the universe's history? Some researchers argue that current simulations rely on unverified assumptions. If the irregularities after the Big Bang didn't occur as we envision, the cosmic web might look entirely different, or might not even exist. Understanding the cosmic web also means understanding how matter is distributed throughout space. Dark matter filaments not only connect galaxies, but also act as channels for the movement of gas and energy. This explains why some areas of the universe are rich in galaxies and stars, while others remain empty, known as cosmic voids. A 2020 study from the Very Large Telescope in Chile discovered massive streams of hydrogen gas flowing along dark matter filaments, fueling galaxies to form new stars. This finding demonstrates that the cosmic web isn't just a static structure, but a dynamic system, nurturing and developing its components. Yet, can we fully trust these findings? Some scientists argue that data collected from telescopes might be limited by current technological constraints. Are the voids we observe truly empty, or are they regions we simply cannot yet see through? This raises questions about the limits of human understanding when faced with the universe's complexities. The story of the cosmic web is a journey into the interconnectedness and organization of the vast cosmos. From invisible dark matter filaments to their formation after the Big Bang and their role in shaping the distribution of matter, every aspect reveals new wonders. But questions remain. Will the cosmic web continue to exist and evolve, or will it dissolve under the relentless expansion of the universe? Are these structures eternal, or are they temporary features in the endless flow of time? These mysteries, though still unanswered, inspire us to keep venturing into the infinite realm of space. Did you ever think about how, in a universe filled with billions of galaxies, there could be regions that are almost completely empty? Spaces without twinkling lights, without clusters of stars or galaxies, just vast stretches of darkness? These aren't flaws or missing pieces in the universe, but an essential part of its grand design. These cosmic voids are not merely the absence of something. They hold a key role in uncovering the greatest mysteries of the cosmos. Let's explore these strange and fascinating empty spaces. Cosmic voids are vast regions of space where very few, if any, galaxies exist. Imagine looking at a map of the universe. Instead of seeing dense clusters of galaxies glowing brightly, you find dark, silent spaces, gaps in the cosmic fabric. These are the voids. They can span from 10 million to over 150 million light-years across, taking up about 80% of the universe's volume, making them some of the largest features we've ever discovered. Scientists have identified these voids through large astronomical surveys, such as the Sloan Digital Sky Survey. One notable example is the Boötes void, one of the largest known, stretching 330 million light-years across. Yet, even within this emptiness, a handful of lonely galaxies can be found, like specks of dust suspended in an endless black sea. This makes voids intriguing targets for studying how matter and energy are distributed across the cosmos. However, not everyone agrees on the nature of these voids. Some scientists argue that they aren't truly empty, but filled with dark matter, a mysterious, invisible substance with powerful effects. Are these voids truly nothingness, or do they conceal secrets that we have yet to uncover? The existence of these voids is no accident. They were shaped by the evolution of the universe itself. After the Big Bang, matter wasn't evenly spread out, but began to cluster into filaments of dark matter and galaxies, leaving gaps between them that became voids. Interestingly, these voids stand in stark contrast to superclusters, the densest concentrations of matter in the universe. A study using the illustrious TNG model revealed that about 80% of the universe's matter is concentrated in superclusters and cosmic filaments, while the remaining 20% resides in voids. This explains why voids lack bright matter. Furthermore, as the universe expands, these voids grow larger, pushing galaxies farther apart and becoming even emptier. But if voids keep expanding, will this lead to a completely fragmented universe where galaxies lose all connection? Some theories suggest that, in the distant future, the universe's expansion could turn these voids into entirely isolated spaces, altering how we perceive the universe's interconnectedness. Cosmic voids are not merely empty regions. They are crucial for studying dark matter and dark energy. Because they lack the bright matter of galaxies, voids offer an ideal environment to explore the effects of these invisible forces. They serve as natural laboratories where the influence of dark matter and dark energy can be observed more clearly. A 2022 study using data from the DESI telescope measured the expansion of voids, providing direct evidence of dark energy's role in pushing matter apart. Scientists believe that by studying how light from galaxies behind these voids bends as it passes through, they can learn more about the nature of dark matter. Yet many questions remain unanswered. Some argue that because voids are so vast and contain so little bright matter, measurements and observations may not be entirely accurate. Are the phenomena we observe within voids truly representative, or are they just small glimpses of a much larger picture we've yet to fully grasp? Cosmic voids are not simply empty spaces, but a testament to the intricate balance of the universe's structure. From understanding their characteristics and formation to their role in uncovering the mysteries of dark matter and dark energy, each aspect opens a new door to exploration. But what happens if voids continue to grow indefinitely? Will they become completely isolated regions in the future? These unanswered questions fuel our curiosity and drive us further in our journey to understand the vast and boundless universe. Did it ever cross your mind how the universe, from a single massive explosion, evolved into the vast space filled with galaxies, superclusters, and voids that we see today? Many people think of the Big Bang as a single moment, but the truth is far more intricate. The Big Bang was merely the beginning, and from that point, the universe has continued to expand, develop, and form the grand structures we know. But what truly drives this process? And where will the future of the universe lead as it keeps expanding endlessly? The expansion of the universe is one of the greatest discoveries in the history of astronomy, and it plays a critical role in shaping the universe's large-scale structures. Imagine the universe as a balloon being inflated. From a tiny point, galaxies are pulled away from each other in all directions. This constant expansion of space has allowed vast structures like superclusters, the cosmic web, and voids to emerge from tiny fluctuations in matter density after the Big Bang. In 1929, Edwin Hubble discovered that galaxies are moving away from each other at speeds proportional to their distances, evidence that the universe is expanding. This phenomenon is known as Hubble's law. Data from the Planck telescope shows that the universe has been expanding for over 13.8 billion years, and this expansion is accelerating, driven by dark energy. However, not everyone agrees that the universe's expansion is the sole factor shaping its large structures. Some theories suggest that gravitational forces between galaxy clusters, or interactions between dark matter and dark energy, also play vital roles. Have we truly understood all the forces at work? Or are there still hidden mysteries waiting to be uncovered? Without dark matter and dark energy, large structures like superclusters and the cosmic web could never have formed. Dark matter, though invisible, acts as the skeleton of the universe, holding galaxies together. Dark energy, on the other hand, is like an unseen force pushing the universe to expand faster. These two elements, while opposing, work together to shape the universe's evolution. Studies from the WMAP and Planck space telescopes reveal that dark matter makes up about 27% and dark energy about 68% of the universe's total energy density. For example, simulations like Illustris TNG show that dark matter filaments concentrate hydrogen and helium gases, providing the raw materials for galaxies and stars to form. Without them, the universe would be a disconnected expanse with no order. But what exactly are dark matter and dark energy? To this day, they remain some of the biggest cosmic mysteries. Some scientists believe dark matter is made of yet undiscovered fundamental particles, while others think dark energy is a property inherent to space itself. Or could it be that both concepts are misunderstandings of physical laws we don't yet fully grasp? These questions continue to drive our pursuit of knowledge. As the universe keeps expanding, what will happen to these large structures? Some theories suggest that they will grow further apart, leading to a future where galaxies and even galaxy clusters lose all connections. This scenario, known as the heat death of the universe, describes a cold, empty universe where matter becomes isolated. Data from the DESI telescope offers deeper insights into the universe's expansion rate, showing that dark energy is becoming increasingly dominant. Some predictions even propose that if the expansion continues to accelerate, galaxies and stars might one day be torn apart in a scenario known as the Big Rip. Yet, there are other perspectives. Some scientists hold hope that the universe could reach a state of equilibrium, where dark energy no longer dominates and large structures remain stable. Will the universe expand forever, or will it eventually stop and collapse? This remains one of the biggest unanswered questions in cosmology. From the universe's continuous expansion to the role of dark matter and dark energy and the possibilities for its future, every aspect is a piece of the universe's grand tapestry. But have we truly grasped its journey? As the universe continues to expand, what secrets will it reveal? And will we ever find answers to questions that have spanned centuries? These mysteries not only propel science forward, but also ignite humanity's boundless curiosity in the quest to explore. The role of galaxies and large-scale structures. Do you ever stop to think about if galaxies are more than just homes for stars and planets? Are they merely shimmering collections of matter, or do they serve a far greater purpose in the evolution of the universe? In reality, each galaxy is not only an isolated entity, but also a recycling plant and a dynamic ecosystem where countless astronomical phenomena take place. Let's embark on a journey to uncover the profound role galaxies play in the grand narrative of the universe. Galaxies are the sites of cosmic recycling, a crucial process that ensures the continuous movement and evolution of the universe. As stars age and reach the end of their lives, they release their material back into space, enriching the surrounding environment with heavy elements like carbon, oxygen, and iron. This material is then reused to create new generations of stars and planets, forming a self-sustaining cycle. Studies reveal that every dying star can release billions of tons of gas and dust into space. For instance, our Milky Way recycles about 1 to 2 solar masses of material each year through these processes. Images from the Hubble Space Telescope show massive clouds of gas within galaxies where old material gathers to give birth to new stars. But is this recycling process always efficient? Some scientists question whether recycled material is enough to sustain a galaxy's growth over time, or if the universe needs new material from external sources, such as streams of matter flowing in from cosmic voids. This raises an intriguing possibility. Are galaxies truly self-sufficient, or do they depend on larger forces beyond their boundaries? Galaxies are not only recycling centers, but also function as independent ecosystems with intricate cycles of energy and matter. From powerful stellar winds to ultraviolet radiation emitted by supermassive black holes at their centers, each element contributes to maintaining the balance of the entire system. In the Milky Way, energy from stellar winds and supernova explosions helps disperse material, encouraging the formation of new gas regions. A 2021 study revealed that hot gas regions within galaxies could reach millions of degrees Celsius, creating high-pressure zones that shape the overall structure of galaxies. These energy flows not only stabilize galaxies, but also influence the larger cosmic web. However, some argue that galaxies are not entirely self-sustaining ecosystems. External phenomena, such as galaxy collisions or the effects of dark energy, could disrupt this balance, Can galaxies maintain their stability over time, or are they merely players in a larger game of energy and matter across the universe? Beyond their internal cycles, galaxies are also the sites of many significant astronomical events, particularly supernova explosions. These occur when massive stars reach the end of their lives, exploding with immense force and releasing energy and matter into space. These explosions not only create heavy elements like gold and uranium, but also have the potential to reshape an entire galaxy. For example, the famous supernova SN 1987A in the Large Magellanic Cloud Galaxy emitted energy billions of times brighter than the Sun. Astronomers closely observed this event, gathering invaluable data on how stars evolve and impact their surroundings. Shock waves from these explosions also compress gas clouds, triggering the formation of new stars. However, not all supernovae are purely beneficial. Some studies suggest that their immense energy could destroy nearby planets or disrupt a galaxy's ecosystem. So, are these explosions catalysts for growth, or do they pose a potential threat to life in the universe? Overall, galaxies are not just collections of stars and planets, but the centers of vital processes that drive the universe's motion and evolution. From recycling matter, maintaining independent ecosystems, to hosting groundbreaking astronomical events, every aspect highlights the essential role galaxies play in the grand design of the cosmos. But have we fully understood these processes? Perhaps greater secrets are still waiting to be revealed, sparking curiosity and inspiring humanity to continue exploring the wonders of space. Have you ever imagined that the universe is not just an immense space, but also a colossal network where everything is intricately connected? Large structures like superclusters, the cosmic web, and voids are not isolated parts, but pieces of a harmonious whole, creating the grand design of the universe. How do these massive components interact and influence one another? And how does this interaction affect the universe's endless expansion? Superclusters of galaxies do not exist independently. They interact and connect through gravitational forces. Imagine standing in the middle of a bustling city, where neighborhoods are linked by roads, bridges, and the constant flow of people. In the universe, superclusters are like those vast cities, connected by dark matter filaments and streams of intergalactic gas. This interaction not only keeps them close, but also affects how matter is distributed across space. Research shows that Laniakea, the supercluster that includes the Milky Way, is connected to other superclusters like Shapley and Virgo. These connections are not only visible through telescope observations, but also modeled through simulations of matter movement in the universe. Data from the Sloan Digital Sky Survey reveals that superclusters not only pull matter toward them, but also shape the movement of neighboring galaxies. However, some argue that gravity alone may not fully explain the interaction between superclusters. Could dark energy, with its role in accelerating the expansion of space, directly influence how superclusters communicate? If dark energy continues to grow stronger, will superclusters completely disconnect, or will gravitational forces keep them linked? The cosmic web forms the foundation that connects large structures like superclusters and galaxy clusters. Picture a vast spiderweb stretching across space, where its delicate threads are dark matter linking the bright beads of galaxies. The cosmic web not only organizes the universe, but also serves as a conduit for energy and matter, acting like the lifeblood of cosmic structures. A 2020 study using the Planck telescope confirmed that dark matter filaments spanning millions of light-years act as bridges between superclusters. Moreover, scientists have discovered massive hydrogen streams flowing along these filaments, providing the raw material for star and galaxy formation. Simulations like Illustris TNG reveal that the cosmic web is not static, but constantly evolving and transforming. But can the cosmic web endure forever? Some theories suggest that as dark energy drives the universe's expansion, the dark matter filaments might stretch so thin that they disintegrate. If that happens, will the universe lose its cohesion, becoming a fragmented space where galaxies drift apart in isolation? The interaction between large structures not only maintains cosmic order, but also directly influences the rate of the universe's expansion. When superclusters pull matter closer together, they slow down expansion in regions with dense matter concentrations. In contrast, in vast voids, dark energy dominates, accelerating the expansion of space. A study from the DESI Observatory revealed that the varying expansion rates between dense regions and voids create a layered pattern in the universe. This not only affects how galaxies move, but also provides critical evidence about the nature of dark energy. Scientists estimate that the current rate of cosmic expansion is about 73 kilometers per second per megaparsec. But this could change depending on how matter and energy are distributed. Yet, the question remains, is expansion purely a simple process? Or are there other unknown factors at play? Some theories suggest that the universe's future is not solely determined by dark energy, but also by how large structures interact. This raises an intriguing possibility. Will the universe continue to expand indefinitely? Or will it eventually reach a state of balance? The connections between the universe's large structures are a testament to the sophistication and complexity of the cosmos. From the interaction between superclusters, the role of the cosmic web, to the impact of these connections on the universe's expansion rate, everything contributes to the grand picture of the universe. But will these links remain strong? Or will they break as the universe keeps expanding? And are there other factors we have yet to discover, silently influencing everything? These unanswered questions drive humanity to continue exploring the vast mysteries of the universe. Have you ever been curious about why, even after uncovering so many secrets of the universe, there are still enormous questions left unanswered? We know that dark matter and dark energy make up the majority of the universe, but what exactly are they? And what roles do they truly play? Could there be intelligent life beyond our Milky Way, watching the light from our galaxy? The universe, despite decades of research, remains a mysterious expanse challenging humanity's understanding. Dark matter is believed to be a key element in the formation and growth of large-scale structures in the universe, yet its exact role remains an unresolved mystery. Though it cannot be observed directly, dark matter is thought to account for about 27% of the universe's total mass energy, acting as the framework that holds galaxies and superclusters together. A study using the Planck telescope showed that the distribution of dark matter can be inferred from how light from distant galaxies bends, a phenomenon called gravitational lensing. This allows scientists to map out where dark matter is concentrated in the universe. For instance, simulations like Illustris TNG reveal that dark matter forms filaments linking galaxies and galaxy clusters together. However, dark matter remains one of the greatest enigmas in science. Some researchers question whether it exists at all, suggesting that the phenomena we observe might result from unknown physical laws instead. If this is true, how would it change our understanding of how the universe has formed and evolved? Dark energy is another crucial factor shaping the future of the universe, but its nature is even more elusive. Dark energy is thought to account for roughly 68% of the universe's total energy and is responsible for the accelerated expansion of space. Without it, the universe might have already collapsed under the gravitational pull of its massive structures. Research using the DESI telescope has shown that the current rate of the universe's expansion is about 73 kilometers per second per megaparsec, faster than initially predicted. This raises questions about the balance between dark energy and other forces. Will dark energy continue to grow stronger, leading to the Big Rip scenario, where galaxies, stars, and even atoms are torn apart? Alternatively, some theories propose that dark energy might weaken over time, leading to a future where the universe reaches a state of stability. But will this really happen? Or are we on the brink of uncovering a new scientific frontier that could redefine everything we know about the cosmos? Beyond the mysteries of dark matter and dark energy, one of the most profound questions is whether intelligent life exists elsewhere in the universe. Our galaxy, with its hundreds of billions of stars and possibly trillions of planets, might not be the only cradle of life. Habitable zones around stars, regions where liquid water could exist, are the primary targets in the search for extraterrestrial life. Missions like Kepler and the James Webb Space Telescope have identified thousands of exoplanets, some of which might have conditions suitable for life. For example, Kepler 452b, often referred to as Earth's twin, lies in the habitable zone of a sun-like star. Discoveries like these fuel hopes that intelligent life might exist beyond the Milky Way. But do we truly understand the requirements for life? Some scientists argue that life could exist in extreme environments, such as the subsurface oceans beneath the icy crust of Europa, one of Jupiter's moons. This raises the question, are we limiting our thinking by applying Earth-like standards to life in the universe? The unanswered mysteries of dark matter, dark energy, and extraterrestrial life not only highlight the complexity of the universe, but also push humanity to delve deeper. Dark matter plays a critical role in shaping large-scale structures. Dark energy dictates the universe's future, and life beyond Earth could redefine our place in the cosmos. But will these questions be answered within our lifetime, or will they become a legacy of knowledge for future generations to explore? The answers lie ahead, waiting to be uncovered by our relentless curiosity and determination.